Greetings and salutations. Welcome to some midweek madness, a video being uploaded on a Wednesday. If you like what you see, be sure and give it a like. It helps to get this kind of thing out in front of new users because it lets YouTube know that people want to see videos like this. And if you are not yet subscribed to my channel, please subscribe. We've got lots more videos coming up about Linux, maybe some videos thrown in there about audio equipment and records too, but mostly about Linux, so stick around for that. I'd love to have you be a part of the family. And thank you to everybody who has subscribed in the last month or so. It's been like an avalanche of people. It's been amazing, so thank you very much. We're going to talk about swap space today. Swap space is virtual memory. It is where an operating system can take things that are relatively idle in regular memory, like physical RAM, and put them in a file or in a special partition on a block storage device, a hard drive. So we're looking at LMDE7, and it's in beta right now as of the recording of this video. It's running in a virtual machine, and when you install this, it creates a swap partition. We used lsblk or lsblk to find that. That shows what all of the block storage devices and all the partitions on them look like on a system. And you can see that we have a 50 gigabyte hard drive here, and the first 4 gigabytes of that is set aside for swap. That means it's a swap partition. And then the next partition is our boot partition, which has the system, and it also has our files for our home directory and all that kind of stuff on it. So why do we need swap, and do we need it in 2025 with all of the memory available on computers? Swap gives the system a way to make better, more efficient use of physical RAM. If that starts to fill up, the memory manager can look at what's going on, and it will take idle things that are happening in memory, and it will page them over to a block storage device. It will move pages of memory. That's what it's doing. In Windows, they use what's called a page file to do this. In Linux and Unix, traditionally, it's been a partition that's set aside just for this on a hard drive hooked up to the machine. But in the last 10 years or so, it has become more common for Linux distributions to not create a partition, but rather create a file to put it in, a swap file. That's what we call it in Linux usually. And so that seems to be what Debian is doing here. If we type in free and we make it humanly readable, you will see that we have 4 gigabytes of memory and 4 gigabytes of swap. No swap is being used. Why do we have 4 gigabytes of memory and 4 gigabytes of swap? Well, at that size of memory, with a modern system, that's about right. You need to have just about as much swap as you do memory. If you go up to 8 gigabytes, that changes. You don't need this much swap. And if you go to 16 gigabytes, you don't need that much swap. The problem with the old school Debian installer here is that if we had 16 gigabytes of RAM on this machine, it would take the first 16 gigabytes of hard drive space to do it. I have not installed this on a system with 24, 32, or 64 gigabytes of RAM, so I don't know whether it does that or not. But 64 gigabytes of swap space is ridiculous. You don't need it. Back in the days when computers had very little RAM, I mean, some of these big Unix systems and early Linux systems would have hundreds of users and maybe only have like 500 megabytes of RAM. Swap was very important, and in those days you'd make your swap partition bigger than your RAM so that the system could actually swap out all of this stuff that users had up and running. And yes, it made for a slow system, but it worked. And these days, like I said, it's not as important, but you need to have it. Some people will tell you, I don't run my Linux system with swap and I don't have any problems. Good for you. The developers say that you need it. the memory manager really needs a place to stick things sometimes in memory. Especially if it's reorganizing things in memory, it may swap something out for just a second or two and then put it back. It's just workspace for the memory manager. And some applications actually demand that they have a little virtual memory, so that way it's there for them. And it's kind of an emergency thing. Even if you have a system that has a lot of memory in it, if you have a program that goes crazy and starts sucking up memory very quickly, you may get to a point where the system becomes unresponsive before it's able to give you an error message to say, hey, I'm running out of memory, something's going on here. Swap will allow you to do that because the memory manager will get to a point and it'll go, wait a minute, I'm putting this here and I'm filling up things with swap. Hold on, I got to let somebody know what's going on. So it's nice to have this running in the background. How much you need is going to depend on what you do with your computer. Most desktop people with over 8 gigabytes of RAM don't need a whole lot of swap space. So we're going to talk about readjusting that today. Now, just to see how much swap is being taken up, you can run the free command. Type it properly, it'll work. And you'll see that we are using no swap at this point, and we're using, what is it, about a gig of RAM. So let's go talk about manipulating this using a swap file. So in this system, because we have this swap partition, unless we repartition the drives, there's not going to be any way at all to make this less without completely reinstalling everything. But we can add more if we need it, but not less, because we could always add a swap file to it. When I do the big video about LMDE, I think I'm going to cover skipping creating a swap partition and creating a swap file. I'm going to show you how to do that in that upcoming video. For now, let's just go ahead and get out of here. And I want to get out of here and go to Ubuntu, because I have that up and running. And I actually do want to change the size of the swap file in this Ubuntu system, and the reason why is because I had adjusted it down to 2 gigabytes, and I think I'd rather have it be 4. When you have a system that has a small amount of memory, like 4 gigabytes, a modern system, you're going to start swapping if you open up a couple of tabs on a browser. I mean, it's gonna have to do that. So what I do is for systems like this, I will provide the same amount of swap space as memory, and that way that expands everything out to 8 gigabytes. So it's like having your cake and eating it too in a lot of ways. So where do we begin? Well, first of all, let's go ahead and open us up a terminal again in this Ubuntu machine. We'll make it big enough for everyone to see, and we'll make that, I think I want that one smaller. Yeah. No, maybe we can get away with this. We'll find out. So we have this Ubuntu. Well, we could full screen this. That would give us more space. Why don't you do that? There you go. All right, we have full screen this now, so everybody can see everything. That's awesome sauce. So let's see how much we have here. We could run free H. That will show us what the swap is doing. That shows us memory. We could use HTOP, which is one of my favorite programs. It shows swap right there. And I have 2 gigabytes of swap space, as I had said earlier. And I want to change that. Okay, hit the wrong key. Thank you, let me out. So where do we begin? First of all, we have to figure out where the swap is stored on this system. I know there's not a partition that's doing it, but we'll just do this to show you guys. So if we go down here, you see that the way Ubuntu is setting this up, this is a non-UEFI machine. They create this little 1 megabyte partition here for boot, which I don't know whether you need it or not, but it's there. And then you have the rest of the drive is set aside for one big happy ext4 partition. So we know we're using a swap file because we have no swap partition. Great. So let's see where our swap file is. It will be in the root directory. And with modern Ubuntu, we're not calling it swap file anymore. We got to get cute and call it swap.img, which is actually more accurate because that's what it is. It's an image of what the system thinks is a partition on the drive. It's just contained in a file. So how does this thing work? When it boots up, it will mount the swap from the fstab file, which is short for file system table, and that lives in etc. So let's grab nano, and we're going to open that up. We're going to look at etc, and we're going to look at fstab. So you'll see on this system, the first thing that is mounted is the partition that's holding the system, right? In the old days, with swap partitions, like if you had a 4 gigabyte system, the way that most people set it up if you were going to do a manual partitioning was to have the root partition be on the front of the drive. Now remember, this is back in the days of spinning drives. And then you would have the swap partition be between the root partition and the home partition. The home partition is where all your data is stored. So in operation, when the system would boot up, it would be reading from the front of the drive. Remember, a physical spinning platter is read from the inside out inside of a spinning drive. And that inside diameter reads faster than the outside. And especially if you're dealing with seek time, because some of the distributions used to place the swap partition all the way at the end of the drive. They would argue that data was coming off the drive faster, which is kind of, I don't know. But the seek time would go up because that head would have to swing all the way to the end of the platter. So you would do root up front, your boot, with all of your system and program files, and then you would do swap, and then you would do all of your personal data. So as the machine was running, the swap would be between where it's going all the time, and it would make your seek time less and all that good stuff. But we don't worry about that too much today with SSDs because there is no real seek time. So you'll notice here that we have a swap file being mounted, and here it is. So it would be root of the file system, swap image, that's that file we just saw. It has no mount point. It is a swap partition, so that would be the file system. And then the rules are SW for swap, and no dump and no pass, because we're not going to try and back this up, and we certainly don't want a memory dump from it. So that's why those are zeros, and that's how it works. So if we manipulate this file here, if we change the size of it, we create a new one or whatever we want to do, then we should be able to simply reboot the system, and whatever new file we add to it, or we resize it or change it or whatever, should work, right? Now, you can also add another file. If you have two physical devices in the machine, we could have swap1 image and swap2 image, and we could mount both of those to the system. And the memory manager in the kernel is actually smart enough to figure out, oh, I have two swap files in two different places. And what it will do is it will actually split the workup efficiently between the two devices. That's if you have a system that's using a lot of swap. For most people, that's not a big deal at all. So that's cool. We know how we've got all the information we need to go forward here. We can change things and mess around and do all kinds of stuff. So let's have fun. So let's get out of Nano. And the first thing that we need to do is, before we start messing around with anything, is turn the swap off. So the command we're using is sudo swap off, all one word, and then we need to tell it where the swap is we want to turn off. So it'd be swapfile or swap.img. That's what it calls it in Ubuntu these days. So that's what we want. So now this is going to turn the swap off on the system. We will have no swap activity, and it will free up that file for us to be able to edit it and play with it and do other things. So let's go ahead and do that. And it asks for my password. And now we need to check to see if we're still using swap, which we should not be. We have 0 swap space, and we're not using any of it because it's turned off. Duh. So now we can manipulate this file. We can make it bigger or smaller, and the best way to do that is just to make a new one. And the way we're going to do that is to first delete the old one. So sudo slash rm slash swap. My brain just stopped working there for a minute. It's like, what are you doing? And we'll go here and we'll get rid of this. Now, before we proceed, please keep in mind that we're modifying the very basic part of the system here. We're talking about deep stuff going on your Linux system. This won't necessarily break your machine, but if you get it wrong, it might screw up the performance. You might end up with no swap space. So if you are at all uncomfortable doing this, I would suggest leaving it the way it is if you don't have a problem. This is not something that you need to mess with unless you have a reason. I'm a nerd, and I'm obsessed with efficient use of hard drive space and all that other stuff. So this is why I mess with stuff like this. If you're not, don't worry about it. So because once we do this, we have to go back, we have to fix it, or it won't work. So it's gone now. We can confirm that just by going here, listing what's in root, and you see, yes, that's definitely gone. So Control L to clear, and we need to now create a file. We need to create a special kind of file. There's a couple of ways to do this. One of the ways is to use a command called fallocate, which basically just tells the file system, create a file and block it from here to here, right? And I don't particularly like that way of doing it because we want to be able to make the file contiguous once we create it, and we have to use a defrag program to do that. And we need to have something in the file for that to work on. We have to create a file with stuff in it, and then we'll turn it into a swap file. So the way we're going to do that is to sudo, we're going to use dd, the disk destroyer command. It's a very old Unix command that's used to copy data from one place to the next. That's all it does. dd is dumb, and it will erase your entire hard drive if you want it to. That's why I call it the disk destroyer. We're going to give it an input file, and that equals dev0. We've talked about dev0 in past videos here lately. And dev0 is a little virtual device that just pumps out nothing but zeros, one after the other. 0, 0, 0. That's all we want. So we're going to make a file and fill it full of zeros. We're going to do OF, that's our output file. That equals swap.img. So we're just going to replace the file that we deleted. And we're going to set a block size, BS equals 1024K. So basically 1 meg, but this is a more direct way of doing it. And then we have to figure out how big that's going to be. Now, for 2 gigabytes, that would be 2048. I want to go back up to 4 gigabytes because this Ubuntu virtual machine has 4 gigabytes of memory. So I'm actually going to give it a little bit more than we had before. So that would be 4096. That is basically 2 gigabytes, or 4 gigabytes rather. Make sense? Good. So we need to make that count equals 4096. That's the command. And yes, they're running off from the fire station as they did in the last video I put up. Go get them, boys. Hope everything works the way you want it to. Okay, so if we have that set up right, then we should create a file that is 4 gigabytes. Let's do it. So it is writing that file as we speak. Okay, it says the file is written. Let's double check that it's there. And we have our swap image file back that we had removed before. But this isn't ready yet. This is just a file with a bunch of zeros in it. We have to make some changes to it in order for it to be swapped. The first thing we need to do is to make sure that the only user on the system that has permissions to read and write to this file is the root user. So we're going to change mod, or change mode actually without the E, 600, and we're going to do swap, no, got to do it there, swap, got to tell it where it is or it won't find it, there. Have to do that with sudo. And to double check that that's done that way, what we're going to do is we're going to ls root swap. We're going to go ahead and list that file, and we're going to look at the permissions and make sure that it's the way it should be. So this is what it looks like. There you go. Yes, that's exactly what we want. Now we have to defrag the file. Even though this is a virtual machine running on a SSD, I recommend that you do this. Remember, we're dealing with virtual memory here. Every little bit of time that it takes to grab anything out of this file matters. And even on an SSD, if the file is in chunks all over the drive, that's going to take a little longer to access than it would if it was contiguous. So we want the file to be contiguous. So we will use e4defrag with sudo e4defrag, and we're going to do this swap file. I'm going to turn that loose, and it's telling us what it's doing as it goes along. This may take a second because it's trying to figure out how many pieces there are of this file, and it's looking for a space to put them that is 4 gigabytes contiguous space. And it's doing it. Let's see what we get. Now, if you do a really big swap file and it comes up and it says that it did it in 2 chunks, that's really not that big a deal for a big swap file. But a small one, we really want it to be contiguous. So let's see what this thing's doing. And so far we're 29%, so it's trying to figure this out. All right, 70-something% there, 75%. All right, it was successful. See over here, it says that we have 1 piece for 1 file. That means it's perfectly contiguous. Now, we need to tell the system that this file is, from this point forward, going to be swap. So what we use is sudo mkswap. That's the command. And we tell it the file. And we're going to do swap. You hear noise in the background. It's my dog. She's wandering around. And the system says that it was able to do that. It issued a UUID, so that is now a swap file. We can make sure that this is going to work as swap by turning the swap on manually, like so. And so we just tell it where it is. We have to do that as root as well. Let's do swap on. Let's see if it worked. Yes, it found our 4 gigabytes of swap right there, and it's saying that we're not using any of it. And so to really make sure this is going to work, we're going to restart the system just to make sure that it mounts the way it should. Reboot. See, I say restart, and I should have typed reboot, and that's what I typed. Go ahead, laugh. Try it yourself. Try and sit here and talk and type and figure all this stuff out all at the same time. Okay, let's get into the system here. And we're going to make sure that we have that there. I'm going to open this up, make it bigger, and we'll run htop. Yes, it says it right here. I've got 4 gigabytes and we're using 0. So that's back to where I wanted it to be. That's how you modify it. We could have made that swap file any size we wanted, 8, 10, you know, whatever size you want to do. You can split them up into parallel swap files. You just add another mount point. It's super easy. So there you go. That is working with swap. I hope you enjoyed the video. The next video should be a look at LMDE7, which is the new Debian edition of Linux Mint, and everybody's real excited about it that is into that particular distribution. I am too, and I can't wait to show it to you. That's coming up next here on the channel. So until then, see ya.